Welcome everybody, this is King Yun Shu. We're back with another programming tutorial. This is where we do functions inside of Solidity. Now it's very similar to C and C++ mainly, and it's a structure-based, object-oriented way of coding. So here I'm going to give you guys some basic examples. You guys want more, we need more collaboration, we need more enthusiasm within the chat and the Discord, so go ahead and join the Discord and show more of a supporter mindset, and go ahead and use the PayPal down in the description. So I figured I show more of the layout of it and you guys can get more creative from there. So in Solidity, it's basically for Ethereum coding, and it is to build different types of layers and different types of alts within the Ethereum ecosystem. So I'll give you guys the layout and you guys can get creative from there. So it's pretty quick. It may take 10-20 minutes, but in general, we'll get right to it. So basically the structure of a function is the same thing as C++, same thing in Java, and those fields. And mainly want to start out with naming what the function is. So it's very similar to the variables that we did from before, the value types, and you're naming what it is, and it's called a function. And the function we're going to do some simple math with this. Is add and uint, which is unsigned integer. No, and external is basically where you're able to use the function after it is deployed, and pure is for something that is its state changing. Let me put a space between that. Turns, and you can put a space here, doesn't really matter. Like I said, it's object programming. We want to return a unsigned integer, right? And then just a basic way of doing the adding. Input inside of the function, and we're going to input this later in JavaScript. You guys see in the title. Same thing with the sub. It's all the same structure. It never really changes based on your logic. Your logic is what you want to put in, and all the structures of the same in Java and C++, JavaScript as well, TypeScript, and Solidity that you see here. And then external is where you're able to use it after it's deployed. Pure, which is not state changing. So, and make sure you guys are knowing each and every syntax. It is very useful from what you're using. Very important as well. Just say if you're making a state change, you put pure, it's not going to work correctly at all. And then the project would inevitably not really communicate correctly towards other contracts. We'll just do 2 for this one. So then we'll keep it like this for now. And then later on, when we have more interaction, we might get more fancy with it. But for now, we'll just keep it as it is. So then you've made a contract with Program Solidity, and then the karen is 0.8.27. That's the version of the Solidity. Let's go to the JavaScript, and the JavaScript is where you want to interact with it. And you're using really Chai and Mocha when you're using these type of testing. So go ahead and make sure we have our hard hat, because we're using hard hat as our environment to test our type of contracts. And then I already named everything up ahead just so it goes a little quicker. It's the asynchronous function of a function fixture. So we'll just remake a fixture. If you guys are wondering what a fixture is, I have a dedicated video on it. I could have one later, and it's really nothing too crazy. So in the future, I can make that. We're basically just creating our owner, and then we're using the hard hat variable to use ethers, and then we're getting all the signers that are within the hard hat testing environment. in its development environment where you have 0 to 19, which is 20 accounts, and these 20 accounts you're able to use and manipulate and interpret whatever you want to do inside of your testing area. So, because generally within your Solidity is all your logic, and you want to change and manipulate your deployment environment. So signers, signer would be the very first, and the signers would be the rest of the 19. So we got all the signers here on this line, on line 13. Then on this line, I'm going to make my variable of controlling the deployed contract. So we're going to get control of it. Take away this. We want to await and then use the same variable to now look into the ethers and look into a deploy contract. And we have to get the name of that deploy contract because we got multiple deploy contracts that you see here, value types that I already did a video on. And the name of it is functions. It has to be the same exact name. It can't be different. It can't be different casing, and it has to be exactly the same. So, and then let's just do a console log. A console log here. And in this console log, we want to just see what this is doing, right? What are we given with this type of variable? And let's say this is the function contract. All right, and then we, inside of a fixture, you want to return at the end the fixture and the owner who's able to use this, let's say, deploy contract, because it's not actually deployed at all. We're just testing it. We have a fixture here. We want to then reuse this fixture in every single describe for best case. You don't want to reuse inside of your testing, which is your its. I went over this already in the past videos. Like I said, all the videos are going to become more and more advanced, so I'm not explaining every little bit as much because you should be watching the previous videos, the previous past broadcasts, and catch the lives when you want to ask a question live. So the function, the owner, and then loading the function right here. So we already have our variables up here, which is our let's get change, and have our function and our owner, let's say, and then we are doing a await. We are in an asynchronous area. Asynchronous area inside of here, right? And then we want to then load this fixture that we loaded up top here. We already have this within our hard hat toolbox and is a network helpers. We then want to say that our loaded fixture is the same name as this entire, let's say, class, because this up top could be like a class within Java, right? So async function fixture, but we're in JavaScript, so we don't really use a object-oriented programming inside of there. So that's finished. So let's do our testing of the adding and the subtraction, and that's really it. So you're just doing what you would do within an application inside of testing files. So you can name your folder test, you can have your file named whatever, just know how to call it, and we will be calling that at the very end. 10 so 20, it could be anything. It's just a sensible number that's within the JavaScript readable view, and to the exact number I don't remember, but you guys can look that up, or we can always do a video on it together when we have more interaction. So, all right, so let's make a new one that we already have the result up ahead, right? Let's go ahead, and this is for organization and keep everything clean. We don't want to redo the same logic, especially when you're awaiting, because we're going to await here. Do a function, the function that we have, we're going to add here and then it's going to be our number, comma, number 2. So within here, I'll explain this because this is pretty simple, but it's not explaining the other ones because we're not doing functions. You're not doing your logic inside of the method, right? Inside the function, inside the method. The code is this, code that, and the same thing. Because you're already doing this logic when you made your business logic here, which is for this one, your addition for X and Y, and then your subtraction for your X and Y. So you're not redoing the same thing. You're not going to be doing a minus here, because then depending on what engine you're using inside of Visual Studio Code, it'll tell you like this is wrong. But you have to then know that before you even are trying to use text editors, because text editors are more loose with it, but people have made different code to now help beginner people with text editors, because text editors are a little more, let's say, advanced in comparison. They're not really advanced at all. It's just less helping. So you should know that. So then that is finished. You can put a semicolon at each and every part. A semicolon really matters if you're doing a type of logic base that's ternary, right? So ternary, if you're doing different things within that logic piece, but usually for best practice, you want to end with a semicolon. So that's like a little reminder for you guys. Go ahead and do log, and then we just want to see what we're doing. We want to communicate back, right? Or we want to have the terminal communicate back to us and see what we're seeing in a human sense. Because all this is going on already, we're just seeing it in a human sense. And lastly, we'll do a expect. Okay, and then this is from our Mocha, either Mocha or Chai, whichever one that comes first is from Chai. Okay, let's say that. Maybe from Mocha in a native way, but it comes from Chai here. And this Chai is coming from Hard Hat, so it may be a little bit fixed on this part just for convenience of the end user. Just indent it a little bit, doesn't really matter. Only matters within Python. This is JavaScript. Let's await. Use a function again. Let's just call the same thing. So we're calling what we're doing just to make sure it's doing what we need to do. You know, that's the only time you want to recall the same function again. But if you want to look back at it with log or even info, just do a variable. Make it easier on you. Make it easier on your other coders you may have. And to then be equal, so we're gonna do a comparison if it's equal to that. Let's do our math in here. So now let's say it should be equal to this, whatever the variable is plus whatever this variable is. And we know what a variable is. It is 10 and 20. It should be 30. So at this test, inside of this testing block, it should be at 30. Realize I didn't say testing or testing block. Should look back at the other videos. Let's just copy and paste this. Let's do it real quick then. Let's do it real quick. 5 and 5. Let's do result. This is how you get your very similar logic to then be copied over and changed by a little bit. I could have copied this over. A bit slower. Copying this over. And then that's it. Sub, and then we are expecting this to be a minus, right? And all good at my notes. So let's go ahead and test this. And you're testing it with the terminal, the PowerShell, most convenient one, and your PowerShell is within the same tree of where your Hard Hat environment is, and you're communicating with this npx hard hat test and where your file is within this folder, in a test folder, and the file is functions.js. So let's see what happens here. Let's say we're clean on the dial on the first time, and we are super smooth. What you finna do? So we're all done. That's how you test your business logic inside your Solidity contract. That's how you do functions in Solidity. That's it, nothing else. If you guys want more, we can do a later video maybe, or most likely a stream where there's more interaction. We could do more things. You guys can test my logic, test things that you want to do but you can't do because you don't have available resources, and we can go a lot harder within these. But for now, I'm giving you the skeleton and the breakdowns of what a function is. A function is to do the same thing within a written area. So that's the most broad way I could say it. So we just did add. We can do add and subtract again. We can do it together. We can do whatever. And we know that this file isn't changing because it is then within an area of doing its own function within a environment called hard hat. So there's functions and models all across to now make everything easier on the end user to then display it across other business logic and servers to now show it on a website, on and on and on, right? So expand your mind, expand what you know about functions, and look over this video multiple times over and over again to get it, and then make your own functions and see you can make more effective logic than me, because then we can get into different kinds of memory saving or memory allocation or anything you want to do in general. But we're eventually getting into that. Usually with UL and assembly, we'll get into that because you can directly control it. So all those big ass words I just said, we're going to get into real soon. Thank you for watching. I'm planning on doing another multi-game stream or just a Yakuza stream you guys have been seeing, but these videos are gonna, or the streams are gonna come back more often than ever, because we got to do some private stuff at the end of the day since it's not a lot of support on the public side. So appreciate you guys watching. It will be more advanced stuff coming your way. Make sure you guys are watching over this over and over again and learning how to do the skeleton of testing your contract and then making the contract within Solidity.